What I would like to do here is to give a short overview of our last sessions of Cytobank intro first. I know most of you have attended some sessions on Monday. For those just joined, they can catch up this way. Then I will go through a few slides on data QC and data pre-processing that's needed for algorithm analysis. I will offer a few tips on the importance of generating high-quality data, especially for machine learning algorithm, which sometimes can be missed. Then I will move on to the demo in-app with some demo data. I will focus on the data management aspect of Cytobank and also show you the basic tools needed for data pre-processing and illustration report. This session can serve as the basic foundation for the downstream data analysis, especially for those interested in the machine learning algorithm session that we will have in the next 2 weeks. So Cytobank is a cloud-based single-cell analysis platform with a focus on high-dimensional data. It is designed for big data management. It is secure, and you can easily share and collaborate whenever you are, especially during this time where you may not be able to physically present at work to get access to your data. With Cytobank, you can access your data from your home computer and even your iPad or iPhone. You can share an experiment or a project with your coworker within Cytobank by one single click. It takes advantage of cloud computing for the analysis and does not take your local resource. We have designed a very user-friendly interface to run the machine learning algorithms, such as VISNI, SPADE, CITRIS, and FlowSum, where biologists can perform analysis without prior knowledge of R or other coding language. Of course, we also provide the API interface where bioinformaticians or data scientists can interact with the data in Cytobank to extend the functionality. We also have the job feature that can be used to analyze non-cytometry data such as proteomics or genomic data. So here's a list of the algorithms available in Cytobank. We have clustering tools like SPADE and FlowSum. SPADE is one of the earliest algorithms developed for mass cytometry data and now also adapt for flow data. FlowSum is a newer algorithm that's much faster and able to take more events and generate quite comparable results compared to SPADE. For the clustering algorithm, it clusters the events into phenotypic similar clusters and a map to the minimum spanning tree. VISNI is one of the popular dimensionality reduction tool, allows you to map high-dimensional events onto two-dimensional plot and still preserving the n-dimensional information of all events. CITRIS is a powerful statistical tool that can be used to identify the significant differences between sample groups. It can help answer questions like why do some cancer patients respond better to immunotherapy but others do not? Why the particular vaccine works better in young people but not in older group? Why are the biomarkers that can help predict these? What are the biomarkers that can help predict those outcomes? In our next 4 sessions, we will go through each algorithm in much more details and show you how to run and interpret the algorithm results, so stay tuned for that. A very often asked question is how to get started with machine learning. For anyone new, we have put together a workflow here as a guidance on how to get started. Like any other cytometry experiment and data analysis, unfortunately or fortunately, the old rules all apply. Before the data acquisition, we think about our hypothesis, what kind of data need to be acquired to support that. Consideration including the number of samples for statistical power, the number of events for rare population, biological and instrumental controls needed, especially to minimize the batch effect. A second step is a post-data acquisition where we need to check on the data quality and do a little bit of pre-gating to get a clean quality data. The model or the algorithm is as good as the data quality you put in. The algorithm is not going to differentiate the positive signal generated from the data issues such as compensation or the true biological signals. So today we will focus on this part, as I said, to set the foundation for more advanced analysis. To run Visney or any other algorithm, we need to make sure we are working on clean quality data. Here shows a simple gating strategy we can use to gate out dead cells and debris with scatter gates. Once you get live singlet, you can run algorithm directly without gating further. Or you can choose to gate on a subset like CD3 and run algorithm on the subsets as needed. Compensation is very important for flow data. Make sure your data is well compensated. Otherwise, the algorithm gonna pick up the spillover as a positive signal and generate false results. Another important factor is the scale transformation. Make sure the arcsign argument is set properly, so you can have a nice peak around the 0 region. If you see a dip like this, most likely you will need to adjust the argument value. The minimum and the max value of the scale won't affect the algorithm run, but the argument value will be. Here's another gating scheme for mass cytometry data. It's a little different gating strategy, but the concept is the same, that you are gating on a clean singlet cells before running algorithm. With mass cytometry data, the compensation and scale is less an issue, as the compensation is very minimum and scales are less dynamic compared to flow data. Other consideration we often see is when you need to compare samples between different runs to make sure the signals are comparable between different batches. There are many factors need to be considered. There are instrument availability, stability across time. There are sample preparation variation, and a well-designed experiment need to take all those into consideration and use proper controls to validate that. In some situations, we can utilize some normalization algorithm to reduce some of those batch effects. So that was a brief introduction to the data QC, and now I'd like to move on to the in-app demo. So Cytobank has a few servers. Most people have an account on the premium.cytobank.org. You can go to the website and create a new account here. You will get 30-day free trial. And today I'm going to use our internal demo server for the demo purpose. I'm going to use my username and a password to log in. So once you log in, here's the experiment manager that you will see. It contains all the experiment you own or the experiment you have permission to access. In order to generate new experiment, you can create this green button here, say create new experiment. You have a few ways to upload data. Either you can create the new experiment via the ACS file. So the ACS file is a compact file that contains all the raw FCS file, the gating ML, and all the advanced analysis you may have, including the algorithms. Or you can upload the data via this normal upload window. You can give a name, create experiment that way. So in this drag and drop window, you can just add files by drag or drop, or add files via this green button. You can also upload the file using a zip file. So once the data is uploaded to the account, it will show up in the experiment manager. So if you go to the mine folder, all the data you uploaded will show up here. The Shared With Me folder contains all the experiments other people share with you, and the Cytobank curated folder are the experiments that made it public by Cytobank. Then the public folder shows all the experiments that made it public by other users on the server. So you can have also other filters like project. You can view the data by project or by PR, the researchers, and also the advanced analysis you have with each algos. You can also view the experiment by labels. So in order to label experiment, you can go to your experiment or your project and click on any of those experiments and say apply label. You can apply label to any of those experiments here. You can also search. I can search for a particular keyword. So all the experiment that have the Cytoflex name on the experiment name will show up on the in the inbox. You can also use other where you can apply labels. You can search for certain keywords. So if I search for Cytoflex, all the experiments that contain that keyword will show up. And you can click on the experiments and apply labels that way. You can also add the settings. So you can add the number of illustration, number of advanced analysis, or you can also add the experiment size. So all those columns is sortable. You can access to your experiment easily from here too. So you can also start a project. So I started my project here for easy access. I set up a demo project setup that has a list of the experiments with all my demo data. If I click on one of the experiments, the preview pane will show me an overview of the experiment where I can have access to all the tabs here. I can share this experiment with my colleague by clicking on the sharing button. Those are a list of the analysis they have with the experiment. It also has a linked experiment session where it shows me the analysis I have done with this experiment. For example, I have a few vicinity, and also under this particular vicinity, I have stitches run on top of the vicinity, and I have a flow sum run on top of the vicinity as well. So this is a very unique workflow in Cytobank where we can run an algorithm on top of the other to combine those two algorithms together. So we can use vicinity as a visualization tool for the clustering algorithms. We will show you the workflow in the later part. And if I click on any of those tabs here, I can go to that experiment. So again, this linked experiment, and also here is a list of the illustrations. As you can see that all my colleagues who have access to the experiment can have their own working illustration and build their own report, so we can work collaboratively on the same data set. Then down here are the number of vicinity I have, and also the bottom is all the FCS file you have in that particular experiment. So on the upper right here is a sharing button. If I click on that, you can see here's a list of the full access user. You can type the username here to share the data with your colleague. Just click on the username, it will be shared. And this is the project access where you can set up the access as view only or full access, where the project members can have view only access instead of full access. So the last one is the experiment can set as public by clicking on this tab. So now this is a public experiment. If you want to make it private, you can click on it, or vice versa. Another data set, a flow data set, to show you some of the basic compensation scales and the gating that's needed for advanced analysis. So you can access all the advanced analysis here, but before we are able to run those analysis, we would like to check on the compensation first. This is a flow data set. So for compensation, we can click on the tab here. There are a few ways to do compensation in Cytobank. You can either generate automatic compensation matrix using the single staining controls, and beads normally works better in this case, or you can import a compensation either from the file internal compensation from the file that you have in your experiment, or you can import the compensation matrix as CSV file, either from other software or from your instruments. But we always recommend that you get your files well compensated, so all your compensation is file internal compensation to make the downstream analysis much easier that way. The second tab is the scales. We're gonna open the scales window here. So in the scale window, you have a list of channels listed here. And if you want to view a channel, you can just click on the, to view a channel, you can just click on this eye icon here. So you can show the CD4 histogram on the graph. And then in Cytobank, we have 3 different scale types. We have linear, log, or arcsine. So in general, for any fluorescence channel or metal channel, we would recommend use arcsine. And then the scatter channel, we can use linear. Then the other column here is called the argument, then the minimum and the maximum of your scale. So for algorithm, it doesn't matter if you set the minimum and maximum correctly to view all the events on the scale, but really the argument is the value that matters most. So this is like the argument defines all the region around the 0. So when you introduce a linear scale on a log, you can define the argument down here so that you can have a nice peak around the 0 region. If you don't set this value high enough, you will see if I change this to 200 versus the 2000 earlier, you will see now you have a peak around the 0 region, indicating not you need to adjusting the transformation to make sure you have a round peak down here. And the algorithm will view this kind of data as a positive peak, medium, and negative population here. So this will really generate some false results. So we would like to get the argument set properly for all your channels. You can view those channels individually by click through, or we can do a lot of bulk editing here, where you can select one or some of the channels and then select the scale type, select the argument, and the minimum maximum apply. So this is bulk editing. You can also import scales from another experiment. So we can import scales from another set of flex data that we have on your server, or we can reset our scales if something's wrong. So this is the scale setting that It's very important to do before any of those analyses, including the gating. So once we have set the skills properly on this data, we can now move on to the gating session. So the Cytobank gating, you can click on the gate tab and bring up this gating window where you will see a list of the gating tools here where you can use to make up gates for your population. And then all the gates will show up down here. So you can make a scatter gate, you can make a live gate and make single leg gates. And then you can set the gates either tailored per file or tailored per population. And then in Cytobank, we also have a population manager where you can define your population out of your gates. And you also have the population tree showing all the hierarchical relationship between your populations this way, or alternatively, you can view the population numbers. So this is another way to visualize your hierarchical gating, a relationship between your child and your parents by the sunburst view. So you can see your gating strategies very clearly with this sunburst. You can also mouse over and get idea of what the percentage of this neutrophil, the event count, and information like that. So the gating, once you've done gating here, in general, as we said, you can just need to gate on the live singulets, and then you can move on to run your analysis. Or you can do further gating, manual gates, to define some of the subpopulations and to compare to your manual gating to compare algorithm-defined populations. We can click on apply and then, or apply and return to make the gates and go to your illustration. So this is a very simple way to define the gates, to define the compensation scales, and then gating. So this is for flow data. If we're going back to the citrus data, we can also looking at this gating window to look at the citrus data. This demo data is a mass cytometry data set where you still follow the same rules of gating. So gate on your single leg, gate on your viable cells, and gate on your subpopulations.
So other than regular gating, you can also import gates from another experiment. So once we click on import gates, you can select an experiment to import from. So this you can use a keyword, use a keyword to search for experiment that you think you can import the data from, or import the gates from, or you can also using the import gating ML to drag and drop a gating ML that you have saved from another experiment into this experiment. Or if you have run the data with a clustering algorithm, so you will have a cluster ID channel, then you can use the automatic cluster gates where you can select. In this case, I don't have a cluster channel with this experiment, but if you have a cluster channel, such as you run a flow sum on this experiment already, you can select the cluster channel and then give the name of that cluster, and then you can generate a cluster gates based on those cluster channel. So this is a very great feature for algorithm run as well.
So for this data set, I have a little bit more samples. So we're going to use that for the illustration. So we can apply and return this to the illustration to bring up the illustration window here. Or you can just go to the illustration tap here and go to my working illustration to go to the illustration page. And down here at the bank, we built the illustration report based on the figure dimensions that includes channel, population, time points. So if you click on the channel, gonna show up down here. You can move those along here. So in order to build those figure dimensions, we will need to set the sample tags first. So you can add time points tag, add individual tag. For example, for this data set, I have 2 time points, convalescence and acute infection versus recovery phase. So we have 10 samples each in each time points. So with that in mind, what we can do is once we set up all those sample tags, we can turn on those figure dimensions and choose a channel to display. So for example here, I'm going to use to search for all the CD markers. So I'm going to select them all. You raise a search for the CD. So I'm going to have all the CD markers listed here. Then I'm going to come down here to choose a population to display. For example, if I want to just look at the singlet cells, we can choose the single cells, choose individuals. In this case, I have 10 samples, 10 each individual with 2 time points. So we're going to choose one patient here, then choose the 2 time points. Then we're going to update. So what you have, you have a column, you have a row as a population, and then you have another individual and 2 time points in the table. Or what you can do is you can move this into a row. So you will have the time points in the row and you have a channel in a column. So we can just say update the illustration. So what you're seeing here is looking at one patient with 2 time points, and then each patient has different channel display in this for this particular population. So you can also add more patients this way. So we can add another person, or you can add them all. So just to show you what it looks like once you add another population, you will see that now you are listing a second patient as the same display as you have at this first one. So you can build up this report as much as possible, and you can also export this this report as either SVG file, or you can export them via this SVG plus here by copy and paste those illustrations out. So this is a very basic demo, and if you want to view more fancier plots, I can go to one of the Disney experiment and check out the illustration from there. Now for this particular Disney experiment, we are looking at all the CD markers at 2 time points with this CD45 positive population, and look at that one individual patient. So you can see now for this patient, you're looking at 2 time points, and for the CD14 marker, you can see that the recovery phase have less CD14, and now this one has more CD14 by looking just the size of the island. So this is a Disney map, which we're going to talk about the Disney in our next session. But this is just a teaser to show you, how we can use this illustration report to identify the analysis results we are looking for with those particular data sets by time points by each individual person. And as I said, you can add more patients from here, or you can add more populations built up on this same illustration. So that to be said, I will stop my presentation here and go into our Q&A session. So please type in your question in the Q&A window, and we're gonna take those questions now. Just last word from here is that, again, please welcome to sign up for the free trial on our premium website. And then we have a lot of tutorials or webinar on the Cytobank YouTube channel. Just search for Cytobank at the YouTube. And then we also have a very good Cytobank blog post. You can check it out. Our support and help portal, you can search for any support articles on this support site, support.cytobank.org, or you can submit any support tickets you may have via the support email we have, or you can submit a ticket from the support site directly. So yeah, that I will end here, and let's take questions.
So thanks for the questions that we coming. Actually, I will give the first question to Steph, and while I switch my screen share to the app. So the question that we have for Steph, the first one is, what happens the data if not completely clean? Steph, can you take that one, please?
Sure, that's a great question. So if the data is not clean, such as you didn't gate out all your dead cells or aggregates, then all those events that don't have really clear biological meaning will be factored into all your downstream analysis. So it's going to give your data a lot more noise and lead to artifacts that are not relevant or meaningful for you. And even worse than that, it could really detract from being able to make interesting and important findings from your data, because it's all kind of distractions from the real clean signals.
So we do get a lot of questions regard to the arcsign and the argument setting. So I think I would like to take the question as a group of questions and answer everyone.
Okay, I agree for sure that she's going to get her recognition. So with that.
Okay, we have a little bit of background noise here. Okay, here, so if you can still view my screen, I'm now sharing the Cytobank demo site here, the experiment. So the argument, if we do have concern over the argument, I have a few tips and also a few resources that we can check on here. So let's go to the other experiment that we just looked at earlier for the flow data. So especially as I said earlier in the talk, it's particularly important for flow data that has a lot of dynamic range of the scale. So if I go to this experiment and we can go to the scale. So for the scales window, if we go back to the scaling, you can see, right, if we view any of the parameters here, so the scaling is really about when you have the, so we have the linear, log, and arcsign. So arcsign is more a by exponential transformation, kind of by exponential transformation scale, where you have a linear and then you have a log at the same scale. So when all the data around zero should be evenly distributed as negative and positive range, right? Due to some of the compensation error or computation error. So when you have a linear range around the zero here, what you're expecting for a good argument or good transformation is where you have a nice peak around the zero region. Whenever you see something that you have a dip around the zero, that's not correct. So we also have a very good blog post about the argument transformation. So if you go to Cytobank, search for Cytobank blog and scaling, you should be able to find that blog post, walk you through nicely of, what is a proper argument and how do you set the argument correctly. So the basic idea is that you change the argument value here to make sure you have a nice peak around the zero region to make sure the signal here is a true positive and a true negative signal. And specifically about the scaling question. So the first one I have here, this Robbins asked, do all the scales have to be set to arcsign prior to using the algorithm? So for algorithm run, we recommend for any of those fluorescence channels, it should be in the arcsign channel. And of course, the scatters can be in linear, and you will never mix different scale types into the algorithm run. So if you will run the algorithm on all the arcsign scales. Do not mix linear versus arcsign because they have really different dynamic range, and that will affect your algorithm. The results going to be very funny if you mix the arcsign and linear that way. So we do recommend you to run the algorithm on the arcsign with the fluorescence or metal channel. And the other question regard to the scaling is, let me just going down the question list here. So the other question is about the scaling only affects the visualization of the data. Is this right? So this is pretty much kind of two steps, right? So you have the argument that affects the visual. You also have the minimum and the maximum value that are going to affect, if the events can be shown on the scale. So for visualization, in general, we wanted to view all the events on the scale so that we're able to define the visualize the events, we can gate on them properly. But however, for the algorithm run, even if you don't have the minimum and maximum set correctly, say you have some of the events are out of the scale, the algorithm can still pick up those signals and calculate. So it doesn't, the minimum and the maximum value really does not affect the how the algorithm calculates the data, but rather the argument will be. So that's why I was stressing it is very important to be sure your scale transformation is set correctly before you run the algorithm, as we do not want to feed the algorithm different scale due to the argument. So that's the thing about scaling. So I'm gonna go down the list here. So the other question about the argument, do you have to adjust the argument for each channel individually? That can be done automatically. So all these scaling adjustment is in this window. We so for sure, like me personally, I like to go through each channel to make sure the scaling is set properly. So it's actually, even though with this type of panel, I have probably 30 plus fluorescent channels here, but still you can go through the list pretty quickly to make sure the scaling are set properly. But you do have the bulk editing, or you can import the scales from a previous panel that you have. So those two options here can make the scaling quite easy if you have a repeating panels over time. So just make sure I answered all the question regard to the scaling. So another question regard to scale is, do you have to do the scaling ungated, or would it be better to scale on cleaned up data that with debris and doublets removed? So I personally like to scale on the clean data. So just my data looks much cleaner. But in general, the debris probably won't affect that much. But yeah, it's a I would recommend to use the clean data for that purpose. It just makes your adjustment much easier. I think I pretty much catch all the question in regard to the scaling. As I said, feel free to go to our blog for the argument paper. Yeah, I personally really want to emphasize this is a very important step before the algorithm run. There are a few other questions. Let me see. Go through the question link. So Steph, you probably want to take this one. It says ACS files are generated in Flojo.
The ACS files, so the ACS files that Chen Jun mentioned can be exported directly from Cytobank. So within Cytobank, you can export the entire package of your experiment, which includes your FCS files, your gates, your compensations, your scale settings. It can include any downstream analysis you've done. You can export that all into one package as an ACS to archive it. And you can download that onto your computer to save it for however long you need. You can also extract the individual components from that. So the ACS that Chen Jun was referring to was what you can make in Cytobank.
Thank you, Steph. So we have another user regard to the account. So how many users can use same Cytobank account at same time? Thanks for asking. So in general, we do not recommend to account sharing. So per our license is one license per user. So each user can have access to their own account with, so that's kind of our license agreement. So Steph, here's a question regard to the compensation. So when you use the automatic compensation on Cytobank, you should use bead or cells. They should have a negative and positive population, or you should use an universal blank.
Great. So within the Cytobank automatic compensation feature, just like any other compensation tool, it's definitely ideal to have clear positive and negative populations. So for that, you will get the best results by using beads. And for each channel, you can specify the positive and the negative population from which file it corresponds to. So I actually have to, I don't recall, okay, now I have to check actually if we can use a universal negative or if it has to go from each sample, but I will check that right now and I'll type it back in when I find the answer.
Great, thanks for checking, Steph. So we have a few questions here regard to the gating. So one is about how do I make sure the imported gating is accurate for my current experiments. So in the gating, since I already have the open here, so we can go to the gating platform. As I said earlier, you do have a few options to either do manual gates here, or you can import the gates with the gates generated previously in another experiment. And then once you import gates, how do you make sure, right, the gates is applied properly or is fit your current data set? So we do have a function here that's called the check gates. So you can just click on the check gates. The gates will be able to show up in the each file of your since I only have one file in this experiment, so I won't be able to tell what the gate looks like for another experiment. So you can actually use this function here to check gates on each individual FCS file to make sure the gates is fit properly with your new data set. Another question I got regard to the gating is about if it's the gate tailored. So it's more tailoring gates. We have two options, either per file. So for example, if I have a scatter gate here on set on sample 1, and when I go through to the next sample, it doesn't look right, and I need to adjust this gates for my next sample. So that's called a tailored per file. So each gate is at different position with different file. And tailored per population, that's really got a concept within Cytobank that we do have the gates versus population. So the gates itself is just it's a coordinates on the plots, right? So this is a 4 coordinates on the plot on the channel CD45 versus site scatter. So this does not reflect the parent or gating hierarchy. So it's a little bit different where you can, if this is ungated, right? If you go to a subpopulation of let's say live cells, right? So the gates is still there, and you still have the same gating. However, now your your active population is changed to the live gates. That's why if you have a say here the naive cell populate the gates that was defined under the CD8 cells, and now you want to tailor this gates to your CD4, that's when you can use the tailor per population to have the same gates that have the same coordinates that's designed under the CD4 population. Let me see if under the population tree here I have, so really it's the naive cells is under my CD4, and those coordinates probably work the same under CD8. I can tailor that gate to the CD8 to make a naive cells under the CD8 population. So that's per population tailoring, and I hope that answers your question. We do have excellent support article regard to gates tailoring. So if you go to our support site, you can check on the for more details. So that's about the gating. I know there's a lot of questions, so I'm gonna go through the list quickly. So there's a question regard to how do I export my analysis as a table. So we didn't mention earlier, but the export action is actually reside under the action button here. So you can export the statistics, you can export the gating ML, you can export the experiment as ACS file as staff and mentioned earlier. So you do have a lot of export option from the action button here. Another question in regard to graphic display. So can you have a black screen with white color text graph? Yes, that's possible. You can do it in the illustration. So we still have a few questions coming in regard to the compensation for flow cytometry data. So one question, Steph, maybe you wanna elaborate a little bit more. I know you already answered earlier regard to the data, if the data not clean. So the question here is what happens if the data is not very well compensated?
Thanks. So I think the effect will be the effect in the advanced analysis, like the Disney plots that Chenjun showed, could be the same as if you were running your dead events or your debris, because those values that you're seeing in the non-compensated data don't reflect the really true values that you want to be using. So that's why good compensation is important. It can also create artifacts from your real signals, and probably even more so, or as Chenjun mentioned actually, that all the concepts that apply to your data preparation for your manual analysis apply to the advanced analysis tools as well.
Thank you, Steph. So I see here we have a question regard to importing gates to Cytobank in Closer, or can we use FlowJo? So it's both for Closer and FlowJo is quite similar workflow. Even though Closer has the plugin that can make the data upload a little bit more easier. So for any, you can pre-processing your data in any other software. So you can pre-gate, you can compensate the data and take the gated population and the compensated population to Cytobank for all the downstream process. So what you do basically is you leave out the, so my workflow in Cytobank normally is go from compensation scales and then to gating before I go into any of those advanced analysis. So you basically, you are kind of escaping the comp and the scaling and the gating process outside of Cytobank. Once you load your data, you already have a clean quality data, so you can start to run your analysis directly in Cytobank. So it's just a different workflow. So you can use any other software in that regard. So Steph, would you like to take the questions that what is the automatic cluster gating used for?
Great. So I think Chenjun is still showing the gating page, right? I can still see that. So after you've done a clustering analysis, which we will talk about in next Thursday's webinar, we'll talk about flow sum. What that does is assigns automatically your cells to different clusters. So a cluster will be a group of cells that look similar to each other. And the automatic cluster gating tool automatically puts all of the events that belong to the same cluster in a population. So using that tool will make those populations for you, so you can use those in your illustrations or in your statistical analysis or anything else afterwards. So you don't have to draw gates on those clusters. The tool does it for you.
Okay, let's move on to the next question here. So there's a few questions regard to when you upload the data and you accidentally include the actual files, or you have a duplicate in your FCS file. So how can you remove or delete that? So in Cytobank, we do not support delete any file. We will think the workflow as archiving. We do not want to modify anything that's uploaded. However, you do have an alternative action where you can use a clone function to selectively clone particular files to a new experiment, so that you don't have to work with the duplicate file or the actual files that way. Or there's a trick, a kind of dirty trick is you can hide the actual files as a compensation file, so that you you can also, by that way, you can also exclude the files from your downstream analysis. So we do also have a few questions regard to the job feature and how to analyze like seek data. So actually we will have the bootcamp session number 6, especially focus on that question. So if you can stay tuned for our next one, our Chi Hao will talk that in much more detail later. I do have a question about the scaling, which is my favorite topic, about scaling for metal tech. So if you are working with mass cytometry data, the scaling is pretty much by default. So the default argument is 5 for all the metal channels. That's in general, we do not really need to scale for the mass cytometry data. It looks quite clean already with the default setting. So for mass cytometry data, both the scaling and the compensation can make much, much easier. There's very, very minimal compensation, and we don't really need to concern that. So I have a question regard to data from different instrument types. So Cytobank can take any FCS format as far as in the standard FCS format. And also, we take pretty much all instruments. So I know some of the cytometer out there have different range of the fluorescence channels. So those can all be adjusted in the scaling window, and even the spectrum data, we can take unmixed spectral data and analyze with Cytobank as well. So there's ways that we can work with different cytometer and different scales to make it work for those advanced analysis. If you have any particular question or run into any issues with your cytometers, please feel free to write in to us. We'll be happy to help. Thank you for asking. Someone said, how much does each license cost? So I will still recommend you to write in to our support, and we will be happy to assist you that way. I'm still going through the more than 80 questions here, trying to, since we only have 2 minutes left, I'd like to take last 2 questions here so that we can end the webinar on time. So we do have a question says, ask which types of files can I upload? Have I upload only FCS file when we talk about the job feature, you will be able to upload any CSV file and convert to FCS format in Cytobank that way. So it's very universal. We can deal with a lot of data types other than .fcs file. So I will take this last question here. It says it's more regard to the project, how to manage the project in Cytobank. So here, if you can still see my desktop here, so that we have a project set up over here. You can set up a new project in Cytobank, and then give a name, and you can create a project here. Then you can add your experience from your to your project. So for example, here I have different projects set up in my experiment manager, where you can see, you can edit the project that way using the, excuse me. So here I have a project set up, so you can view the project, you can edit, you can do a lot of management with data management within the project. So this is a great way to organize your data. So that to be said, I hope I answer most of the question here. For the question that hasn't been answered, we will get back to you individually. And well, thanks for joining the webinar today. And thanks for your time, and see you next Tuesday. Bye for now.